Hi, so in today's presentation, I want to finish up talking about alternate energy sources with biofuels and hydroelectric. So we're just going to hit the highlights here. I want you to make sure you also check in your textbook. There's a lot of good information in there to sort of fill in the blanks. Okay, so biofuels are basically fuels that are made through biological processes. The most common ones we're going to run across are ethanol and biodiesel. Okay, we can also use methane that's made from biological processes. So for instance, remember when we talked about landfills? So as things in landfills decompose, they make methane, which normally then gets off-put into the air, which is a global warming gas. So if we can capture this, and remember methane is our natural gas, we can use it as an energy source. The ethanol that we use generally either comes from sugarcane if you're in Brazil or from corn in the US. There's a lot of research into trying to figure out how to get it from other materials, especially like waste materials. So for instance, instead of using the corn, use like the stalks and the leftover pieces so that you're not directly competing with a food source. All right, and when we think of bioenergy, there's actually three main things you're going to use it for. So direct combustion for heating. So especially in the developing world where you're still going to use wood, charcoal, or manure, let's say to heat your house or use to cook things in your stove. One of the problems here could be indoor air pollution, so you need appropriately vented oven, for example. Biopower for generating electricity, so you're still burning it, you're just doing it in a larger scale at a power plant. Here's that landfill gas we just talked about, so that's the methane that comes from landfill. And then biofuels for powering vehicles. So this is going to be ethanol that's either produced through corn or sugarcane residue, or some crop that's used to generate biodiesel. So those are the main ones you'll come across. And one of the issues that we run into, especially in the US with using corn, is well, you might think, well, why don't we use more corn and make more ethanol? All right. But think about how much land that would actually use up. And corn is a really intensive crop. You have to put a lot of inputs, a lot of fertilizer and pesticide to making corn. So it's not really a good substitute here, even though the ethanol produced does make a cleaner energy source. It's competing with food that we eat and that livestock use. So using it as part of gasoline is going to drive up the prices, which can really impact basically food availability in a lot of areas in the world. Okay, if we look worldwide, so here's, let's see, Brazil is in the dark blue, the US is kind of gold, and then down here is the rest of the world. So I've kind of put the arrows here so we can see. And clearly Brazil and the US use the most of this, and it's really increased since, let's say, the year 2000 here. And this is a big political issue in the US. I think I've mentioned this a number of times, but when politicians go to Iowa, they're going to support corn used for ethanol because that really supports, keeps corn prices high, which is good for farmers, and it keeps them having basically a place to sell their crop. So politically, it's good in the US. All right, and biodiesel is another way that we can use biofuels. And one thing I wanted to bring up here is palm oil. So you may remember we talked about palm oil when we talked about destroying the Indonesian tropical rainforest. So remember palm oil plantations? So basically you burn down the rainforest, you plant all palm oil trees, and then you use that. And so a lot of food now says, you know, palm oil that's been sustainably harvested, and you should pay attention to that ingredient. But it's also used in Europe to make biodiesel. So this is still an issue, even though biodiesel may be cleaner. Where are you getting the biodiesel and what's happening on sort of this end of the picture? So here are some advantages and disadvantages to various types of gasohol. So cleaner fuel, less impurities, actually less CO2 emissions. It's renewable. So if you think of corn, you can grow more, right? And when you think of carbon dioxide, it's different than fossil fuels in that when the corn's growing, it's taking in CO2 from the atmosphere. You burn it, it releases it back. So that at least is kind of a closed circuit. But look down here. You have to add in large amounts of fuel to grow, harvest, transport, and distill the crop. So there's a lot of inputs here and pesticides and machinery that are making this not as good as it first sounds. And then also as you're growing this, think of you're removing all those nutrients from the soil. But it does create jobs and it helps the economy in a lot of areas. Disadvantages is it burns hotter. So you need, if you're going to go over 10%, you need a special engine. And it actually makes the fuel consumption efficiency a little less. So you'll get less miles per gallon if ethanol is a part of the mix. And then we talked about how it's at competition with food and livestock feed industries and causes a rise in food prices. All right, in the US, using corn for ethanol is actually subsidized, so that makes it more profitable. All right, one thing I wanted to mention here, just because we have these in Baltimore, so I think it's interesting, is generating electricity using trash incinerators. So Baltimore has two. Wheelabrator is the one in South Baltimore that you've probably maybe seen from the highway. And basically what happens is every day, right, tons of Baltimore trash gets delivered to the incinerator. So Baltimore City and part of the county, actually all of that trash goes to Wheelabrator. And it's burned at really high temperature so that all you have left is like ash, basically. So it really decreases the volume of the trash. The heat is used to generate steam, which is used for electricity. And there are pipes that lead from Wheelabrator directly to buildings downtown. So it heats a lot of the downtown area with steam. So this is sounding pretty good. We're getting rid of garbage. We're generating electricity. We're kind of doing two things at once. Sounds kind of efficient. There are 75 waste-to-energy incinerators now in the U.S. That's down from 97, though. So what's going on? Why aren't there more? Well, so a lot of people think that this is too much pollution, right? So you're burning trash. What's in that trash? And how do you monitor it? The EPA does actually put waste-to-energy plants ahead of landfilling because you're not taking up all this space and you're generating fuel from this. And Wheelabrator is in compliance with state and federal regulations. But it's very controversial in Baltimore. So it's right in the middle of a community, so downtown South Baltimore, and it's the biggest polluter in the city. So Baltimore City Council passed an ordinance that would require them to meet higher standards and do more reporting about their various pollution. And they say that this would increase their prices too much and they wouldn't be able to do it. And probably right now, I think it's still in the midst of a court battle to see whether the state, in fact, can control the pollution controls or whether that's a federal and state government purview. But anyway, you will hear probably some issues with trash incinerators. There was one a little while back in Frederick that they wanted to build that got defeated because of bad publicity. And here's just a picture of the giant claw in the incinerator delivering trash. Okay, hydroelectric is the other thing I wanted to briefly mention. We talked about this when we did the water chapter, so this should be pretty familiar. You build a dam that creates this reservoir behind it. As you let water through the dam, it's going to turn a turbine, which then turns a rotor, and you've got magnets here that generate electricity, and that can be used directly, right, to power homes and everything in the vicinity. This is renewable, so as long as there's water that's coming down into this reservoir, the dam will keep functioning and keep generating electricity. Some examples that we talked about in the water chapter, remember Three Gorges Dam is in China. So there were 1.2 million people had to be relocated. So this was a really vast area. Colorado has two famous dams, the Glen Canyon Dam and the Hoover Dam. And I've written down here, you can see some of the issues that we've already talked about. So when we look at advantages and disadvantages, advantages, high net energy gain, high efficiency. So hydroelectric is actually one of the most efficient electricity producers. The reservoirs we can use for recreation and irrigation. So you may have gone like, canoeing on Loch Raven. So that's useful. It can be used for flood control. They generally, once they're built, have long lifespans. It's completely renewable. And really, it's very low carbon dioxide emissions. So actually generating the electricity, there's no CO2. The only CO2 comes in when you're building the dam and maybe doing some maintenance. Disadvantages, it costs a lot. You divert the river, interfere with fish migration. There's all that drowned river valleys behind the dam. The change in water temperatures. So in the reservoir, it's colder, and downstream, it's hotter. So these are various types of thermal pollution. And this may change more rapidly than would normally occur. And then sediments can be trapped behind the dam. All right, and I just wanted to mention a couple things about energy conservation. 3 things I want you to think about if this is ever a question is you can either approach it by using less, you can be more efficient with what you do use, and you can think about how you could switch sources to be more, to increase energy conservation. All right, so let's look at some things. How can you decrease energy for transportation? Trains, public transportation, carpooling, right? Decrease energy for heating, right? More insulation, better building construction, decrease electricity use, use energy efficient appliances, turn down your thermostat, right? Here's the efficiency, these Energy Star, cogeneration, that's what we just talked about with the wheelabrator, right? Use excess heat from power plants to produce steam to heat nearby buildings, right? Building design. How do we orient them to the sun? How do we shade them? What materials do we use? All right, CAFE standards. Those are the standards that tell car manufacturers how gas efficient the cars have to be. These were increased under Obama. They've since been decreased again under Trump. But keep your eye on these. This is one way to lower how much gasoline we use. And then using things like hybrid electric vehicles, which we'll talk a little bit about in later unit. All right, and then here I just wanted to kind of put some learning checks in. We've done 2 chapters now. We've done fossil fuels and our conventional alternate energy. So here are some things you should be able to do, and if not, go back and look. So identify differences between renewable and non-renewable energy sources. Describe trends in energy consumption. How is it distributed? Where is it most widely used? Developing versus developed countries, overall demand, what influences which ones we choose, right? Availability, price, government regulations. Where do natural energy resources occur? All right, types of fuels and their uses. Describe the use and method of fossil fuels in power generation. So how does that work, right? What's that combustion reaction? How does it generate electricity? How are each of them extracted? Coal, oil, natural gas. Describe the effects of fossil fuels on the environment. Coal, oil, natural gas. What are the pros and cons of each of those, and what's the effect on the environment? All right, describe the use of nuclear energy. Describe the effects of that use on the environment. Describe the effects of the use of biomass in power generation on the environment. Describe the use of hydroelectricity in power generation. Describe those effects on the environment. And then finally, you should be able to start to describe methods now for conserving energy. And again, we'll talk about these a lot more when we talk more about solar and wind. But for now, think about your answers. Small scale, how would you do this around the home? And on a large scale, how can we do it as a population, a country, or as the world? Like, what are the different things? So we talked a little bit about those. Your book has some great information on that. So that's kind of your outline for what we've done so far in our energy unit. Okay, I hope that was helpful, and I'll see you next time.